This is the CPU, or Central Processing Unit. This is the brain of the computer. It reads program instructions and executes them, and also relays information to and from the other devices. These are examples of input devices. They are devices that transfer information into a computer. Information going into a computer is called input. Conversely, these are output devices. They take information from the computer and turn them into output that the user can understand.
Let's move on to memory. There are two main categories of memory, main memory and auxiliary memory. We'll start with main memory. Main memory contains storage boxes. Each box contains a piece of information. For example, if a program stores a last name, such as Smith, then it would use 5 storage boxes. They are stored here with an address specific to each box. An address is a specific location, much like a postal address that uses street, city, and zip code values to specify a location. A computer addresses the information's position within the main memory to specify a location. Main memory's first storage box is at the 0 position, so you would say it's at address 0. The second box is at the 1 position, so it's at address 1. Main memory deals closely with the CPU because the CPU needs to be able to access and store information with great speed. This is why main memory is located on the motherboard, close to the CPU. You could think of the main memory as your closet, which you use to store things you need the most. Auxiliary memory is like your garage. You use it, but you don't use it as often. Something to keep in mind is that main memory is volatile, which means that data is lost when power to your computer goes off. There's another kind of memory that will save your information when power goes off. It's called auxiliary memory. Auxiliary memory comes in many different forms, the most common being the hard disk drive or HDD, CDs, and USB flash drives. Those devices are called storage media or simply storage devices. Next we'll talk about software, starting with the operating system. An operating system, or OS, is an interface between hardware and software in a computer system. The operating system is responsible for the management and coordination of activities and the sharing of limited resources of the computer. The operating system acts as a host for applications that run on the machine.
We'll talk more about applications later. The main purposes of the OS are to handle the details of operation of the hardware. This allows applications to focus only their purpose instead of trying to manage the low-level details of hardware, which makes them easier to write. Operating systems run using user interfaces or UI, like keyboard commands to command line interface, CLI, or using a keyboard and mouse with a graphical user interface, GUI. Common operating systems include Mac OS, Windows, and Linux. Back to application software. Application software is any tool that functions and is operated by means of a computer with the purpose of supporting or improving the software user's work. Let's use an analogy. For example, the relationship between a light bulb, application, and a power plant, a system. The power plant generates electricity, not really useful until it's harnessed to an application, like the light bulb that performs a service which benefits the user. Very common examples of applications are word processors, spreadsheets, media players, and database applications. Now we'll talk about computer networking and the internet. Early computers were standalone computers, designed to only be used on a personal level by an individual. However, doesn't it make much more sense to share resources? The answer was yes. For example, early microcomputers, computers with large-scale integrated circuits or computer chips, required a dedicated printer. But wouldn't it make more sense to have many computers share a single printer? Wouldn't it also make much more sense to share data among computers instead of duplicating the same data on individual machines? Wouldn't it also be nice to communicate with electronic messages between the computers? That's a lot of questions. These ideas led to the development of a connected network. There are different types of networks. For example, a network that connects computers in a single building or in several nearby buildings is called a local area network, or LAN. A network that connects geographically dispersed computers is called a wide area network, or WAN. In connecting these individual networks, you get a form on interconnected networks called internets. The most famous of these is simply called the Internet.